Welcome back to your final exam review for Algebra 1 Semester 1. We're dealing with problem 59 for this year, and 59 doesn't include two graphs. I put the two graphs in here though because they really help me, and on your actual test, on your final, they're going to give you a whole blank page of graphs. So if you get to a problem like this one, I would suggest using one or two of those graphs. So let's take a look. We have the functions g of x and h of x, and I'm just going to build each function to start. So g of x is the result of reflecting the graph of f of x equals the absolute value of x. So let's start with maybe what f of x is, because that's the same in each one, and I'll do that one in green. So f of x equals the absolute value of x is known as the parent function. I'll write that for you. It's the parent function for absolute value. Our parent function always starts at 0, 0. And then we have that invisible slope that's in front, that 1, and that's going to tell us to go up 1 over 1 in each direction. And I'll put a few more of these just so I can be a little bit accurate here. It doesn't have to be perfect, but it's going to look something like this. So here is my V-shaped original parent function. And I'll call this f of x just so we can keep it straight. Now I'm going to do the same thing over here. Hopefully you're following along and doing the same thing. It's good practice to get that parent function down there. The parent function is the one with the easiest slope, right? Up 1 over 1. And it also hasn't been translated from the vertex. It's just stuck right at the vertex. Okay? So then let's say, all right, what happens for g of x? And I'll do g of x in red. G of x is the result of reflecting the graph of f of x over the x-axis. So I'm going to start with this piece. If I reflect f of x over the x-axis, it's going to look just like this. Same thing, but now it's flipped downwards. And then translate the function up 1 unit. So I'm going to take this red graph and move the entirety of it up 1 unit. So if I take this point and move everything up 1 unit, it's literally just like you're picking up the graph and moving it 1 unit up above. So it looks something like that. So I'm going to erase this so I don't get too confused here. And here's my graph g of x. Okay. Then we have h of x. So h of x I'll do in blue. H of x is the result of translating the graph up 1 unit. So the first thing I need to do is bring this green graph up 1 unit. It's going to look something like this. Then reflect the function over the x-axis. Now this one throws people off because some people think, oh, I heard reflect, so that means it just flips down. But you've got to be very careful. It's not just going to flip down there, it's flipping over the x-axis. And right now, this graph is like 1 above the x-axis. So when it flips over, that vertex that was 1 above is now going to be 1 below. And our graph is going to end up looking like this. I'm going to get rid of that so we don't get confused. And there's my new function, h of x. Notice that same gap that was up above is now down below. So we have h of x and g of x. G of x, we just need to figure out the equation for, and then we should be set. Now, g of x is facing down. Because it's facing down, if we think of our hk form, right, that hk form is that m absolute value x minus h plus k. The facing down part has to do with the slope. So my slope to be facing down has to be a negative number, and that's the same thing for h of x as well. So if we look at these two, okay, we know they have to have a negative slope, and they all have negative slopes. That doesn't help. We're like, dang it. Okay, let's see what else then. We also know that g of x is 1 unit up. Up and down movement in hk form is always given by the k value. And I like to joke that k stands for the vertical movement, and I misspell vertical. But yeah, k moved things up and down. And if originally we started at 0, 0, and now we went up 1, that to me tells me that k is going to be 1 for g of x. So g of x is going to equal something negative, and then k was 1. Notice that our vertex didn't move side to side, it only moved up and down, and because it didn't move side to side, our horizontal, that one makes sense with h, right? Our horizontal would have been 0. And then our slope didn't really change, it's down 1 over 1, down 1 over 1, so our slope looks like this. Now that's not going to match anything over on this left side because most people won't write the zeros and they won't write this 1 out front. The 1's assumed, so they're just going to put the negative. x minus 0, anything minus 0 is itself, and then plus 1. And I think this will be the equation for g of x. And we'll notice that that doesn't match b, it doesn't match c, it does match d, it does match a. So then it really comes down to h of x. H of x we can do a lot faster. H of x is downward facing. That works great for both of those. But then it's moved 1 unit down. And that negative out at the end is what's going to move that 1 unit down. This positive would have caused this graph to be moved up here, right? That's the same as g of x. And so we end up with